Hey everybody, welcome back to my channel. Today's video, I want to continue our discussion of polynomials, and just as a quick disclaimer, I feel like this is one of the more difficult topics that I teach every year in Algebra 1, so doing it by video is going to make it a little bit more challenging, so I'm going to try to break it up. We're just going to do a little piece today, we'll do a little piece tomorrow, and then probably have to do a little piece again on Friday. This is going to take a little bit of a time just because it's a little bit tough, but I think with a little bit of practice and a perseverance, we can get through it. So you can see what we have here today are more polynomials, but if you paid attention to my title, Factoring Polynomials, I didn't have this on my previous videos the last couple days. The other day, it just said x squared plus bx plus c. You know what that means is, yesterday our questions would look something like this or something like this, where, and it doesn't really matter what numbers I'm putting. Over here, what I really wanted to show you is, over here, our first term was always just 1x squared, or 1y squared, or 1w squared, or 1j squared. There was always an imaginary coefficient of 1 on these. And that's the reason that we could always do them in our head with that little mental math trick, where we would think, oh, what two numbers multiply together to equal something that add up to equal something, right? The only reason we can do those in our head is because they had a coefficient of 1. The a is 1 on those, and that means you can do them in your head. However, will this always be that way? Is every single question going to have an a of 1? And the answer is no. Like, look over at these examples, right? I've got 3 as my coefficient. On this one I've got 2, and on this one I have negative 4. And so what do you do whenever the a is not 1? Right? Can I do them in my head with the little mental math trick that I did on the last ones? No, I can't, right? If you try that on this one, just look what would happen. If you tried to say, hey, what numbers multiply together to equal 36 that would add up to equal 21? There is no combination, right? The only way you could get 36 is you could do 36 times 1, you could do 18 times 2, you could do 12 times 3, you could do 9 times 4, you could do 6 times 6. Do any of these combinations add up to equal 21? Nope. 18 plus 2? Nope. 12 plus 3? Nope. 9 plus 4? Nope. 6 plus 6? Nope. And so it doesn't work doing the little mental math questions that we did the last couple days. And the reason it doesn't work is because this has a 3 at the beginning instead of a 1. Your a on this question is the number 3. So what do you want to do? How do you want to attack these if you can't do it with the little mental math tricks that we did the last couple days? Well, this board is actually the easiest board we had today. What you want to look at first is a greatest common factor. Do these 3 terms in the trinomial, do they all have a number that they all go into? Is there a number that you could say 3 goes into this number, 21 goes into this number, and 36 goes into this number? And I hope you thought of one, right? All those numbers can be divided by 3, can't they? So what you can do is say, all right, I'm going to divide, or what some people say is they call it factoring. I'm going to factor out the number 3. I'm going to divide every single term by 3 and see what's left over. For example, 3x squared divided by 3, 3 divided by 3 is 1. I'm not going to put a 1 on there, but I'm just going to put x squared. In the middle, 21x divided by 3, or we're going to factor out a 3. 21 divided by 3 is 7 x's. And then at the end, the plus 36, we're going to do that as well. 36 divided by 3 is 12. And so if you look at the statement I have in the parentheses now, doesn't this look exactly like the questions that we've been doing the last couple days? It does, right? Now that I have just a regular x squared, now that my coefficient here is 1, now I can do it in my head. Can I think of 2 numbers that multiply together to equal 12 that add up to equal 7? I hope you can, right? Think about that. Are there 2 numbers that multiply together to equal 12 that add up to equal 7? It's 4 and 3, isn't it? So don't forget, whatever we factored out, whatever we divided by, that has to go at the beginning. If you're like me, you always forget to put that on your answer because you're so excited, like, ooh, I just figured out the little brain teaser. I know the 2 numbers are 4 and 3. And there it is. So it's x plus 4 times x plus 3, and the whole statement is multiplied by 3. That number that you factored out, it has to go at the beginning. You could technically put it at the end, but no one ever does that. It's going to look a little weird, and people are going to look at you funny if you try to put it at the end. Okay, let's look at number 2. Same idea. Do these 3 terms all have something in common? Something that we could factor out, right? Is there a number that we can factor out here that they can all be divided by? And I think common sense tells us we can divide all those by 2, right? So let's go ahead and do that. If I do 2 divided by 2, I get 1x squared. I'm not going to put the 1. I'm just going to put x squared. 16 divided by 2 is 8. And here, 30 divided by 2 is 15. And now in my purple parentheses, I have a statement that looks like what I did the last couple days. This is just a regular x squared. My a is 1. So that means I can do it in my head. Is there a combination of numbers that will multiply together to equal 15? That will add up to equal 8? I think there is, right? Isn't that 5 and 3? 5 times 3 equals 15, and 5 plus 3 equals 8. So my two magic numbers are 5 and 3. Don't forget that 2 at the beginning that we factored out. And now my two magic numbers are 5 and 3. Doesn't really matter the order. You could put 3 in the first parentheses and 5 in the second parentheses. It doesn't honestly make a difference. But there you go. Okay, one last one. My third one on here is a little bit trickier because it starts with a negative coefficient. The leading coefficient is negative. Does that really change the way we do it? A little bit, but not too much. How does this change things? What this means is instead of dividing, let's see, we could divide all these by 2. We could also divide them by 4, right? Whenever the first term, the leading coefficient, is negative and it's in standard form, right? It goes highest degree to lowest degree. When it's written correctly and the leading coefficient is negative, you always want to divide by a negative number. Even if it's just -1, you never want to have your leading coefficient negative whenever you're doing a question like this. So I'm not just going to factor out 4. I'm going to divide everything by -4. So be careful. This is going to maybe trip some people up. -4 divided by -4 is 1. Here's where you're going to mess up if you make a mistake. -4 divided by wait a second, I said that backwards. I messed up. -8 divided by -4. Negative divided by negative is positive 2x. And here, positive 60 divided by -4 is negative 15. And now in the parentheses, I have x squared plus 2x minus 15, right? If you had forgotten to divide by -4 and you just divided by +4, you would have had a negative x right here, and then you would have been stuck because you don't have any experience doing these when it has a negative sign at the beginning. And that's why it was important to divide by a negative. Can we think of two numbers that would multiply together to equal -15? And those same two numbers would add up to equal +2? I think I got it, right? When I think of -15, I think of 5 and 3, right? So -15, that means one of them has to be positive and one of them has to be negative. My answer has to be +2, so that means the bigger number has to be positive. How about this? +5 and -3. +5 times -3 would equal -15 if I multiply them, and 5 minus 3 equals 2 if I add them, +2. So that checks out. Okay, there it is, guys. Those questions are actually pretty easy. Those are not too tough. Factor out the greatest common factor if one exists, and then you can solve it just like we have the last couple days. Now, I have just a couple more boards here. I have 4 questions. Here's where the first 2 are going to be. You might be thinking to yourself, all right, buddy, that seems pretty easy. But what happens if there is no greatest common factor? Oh boy, right? And here's where it gets a little bit tougher. Here's where 8th graders in the past have kind of, I don't want to say been frustrated, but they just kind of get annoyed because there is no just easy strategy, right? There is no just quick way to do it in your head. You have to do guess and check, which means we're just going to guess our combinations until we find them. We're going to check them out. We're going to guess until we get them right, and we're just going to have to check and just keep checking until we get the right combination. That's kind of annoying, right? And I don't know how you guys are out there, but my students in the past sometimes get annoyed with this because like, oh, it's so much work. I got to work all this out. Oh my goodness. Oh, right. It's just they're kind of annoying. I know. Just suck it up. You can handle it. So what you'll notice here on number 1 is there is no greatest common factor, right? I cannot divide all these numbers by 2. You're like, well, 7 divided by 2, that's really 3.5. Can I do 3.5? No, sorry. We can't have decimals in these. So we can't divide all these by 2. The only number I could technically divide them all by is 1, but if I divide something by 1, that really doesn't change it, so that's kind of worthless. So what we're just going to have to do is guess and check. Now, here's how it works, and it's kind of tough, so just watch me. If you need to rewind the video and pause and go back and watch this again, feel free to do it. Watch it as many times as you need. We're going to try to piece together how they got this as their answer, right? We know it had to be 2 parentheses. What did they multiply together to get this as the answer? Now, I'm not just guessing randomly, because that's going to be really frustrating. Use educated guesses, right? Look here. This is the first term. How did they get this as the answer? 2x squared. What would be the only way they could get an answer of 2x squared? What would they have to multiply together to get 2x squared? Right? Isn't the only way to get 2x squared to do 2x times 1x? Right? 2 times 1? Now, they could have it flipped around. They could have 1 times 2. But it's got to be the combination of 2x and 1x. That's the only way you could multiply stuff together and get 2x squared. No other possibilities. Right? And then once I focus on that, I look at the end. I'm going to try to build my foil here, right? I've got F and L. I'm going to put O and I in the middle here in a second. What are the different ways that we can multiply stuff at the end to get an answer of 6? Well, there's 4 different possibilities, right? They could have done 1 times 6. They could have done 6 times 1. They could have done 2 times 3. Or they could have done 3 times 2. It's one of those 4 choices. There are no other choices that exist using just regular whole numbers, right? No decimals, that would give us an answer of 6. Those are the only 4 combinations. Now, it's always helpful to sneak in the inside here. This is our target. This number right here is the one that I am not sure of, right? Circles there look kind of pathetic. This is the oi, the O and the I, the oi, and that's what we're looking for. We're going to try to guess which one of these 4 combinations. We're going to plug one of these 4 combinations into my parentheses. We're going to work out the oi, the outside and the inside, and we're going to see which one of the combinations adds up to equal this. This is our magic target right here, positive 7x. So let's just, for fun, let's just try the very first one. Let's just try 1 and 6. 1 and 6. Now, with my experience, usually they don't use the combination that has the number 1 in it, but just for fun, because we didn't know any better, we're going to act like we tried that one. If I was doing this on my own, I would try the combination that has 1 in it is usually the one I should do last, but we're going to act like we didn't know any better since this is the first time we've ever learned it. We're going to check the oi, the O, and the I. The O stands for the outside terms. So I'm going to do here, on the outside, 2x times 6. That equals 12x's. 2 times 6 equals 12. And then on the inside, some people do it like this, right? 1 times 1. 1 times 1x, that equals 1x. And so if I look at my answer for my O and the I, the oi, I got 12x and I got 1x. Does 12 and 1 add up to equal 7? Obviously not. So this is not the right combination. So now I want to try the other combinations, right? Maybe let's flip it around. Maybe it's the 6 in the first parentheses and the 1 in the second parentheses. So look how I'm doing this. This is very important. Did I erase my first combination? No, I did not. I think it's a great idea to keep it all on the same piece of paper. Don't erase it and then do your next one right over the top of it, right? What's happened in the past is kids, they would erase their first combination, then they'd try another one, that wouldn't work, then they'd erase it, they tried another one, that wouldn't work, and they'd end up just erasing everything, and then they'd get themselves confused because then they're like, well, I can't remember which combinations I've tried and which ones I haven't tried, and that's why I just say keep it all on your paper. That way you can have a nice organized list. I'm going to try this, then I'm going to try this, then I'm going to try this, then I'm going to try this, and it's all right there, because otherwise you're going to erase it and you're going to forget which ones you've tried, and the next thing you know, you've lost it and you're starting over and you're really frustrated. So let's try this one. Notice what I did. The purple numbers did not move. I kept the 2 and the 1 in the same spot. The only thing I flip-flopped were the 1 and the 6. Instead of having the 1 and the 6 here, I flip-flopped it and put the 6 first and the 1 second. So let's just try that. The oi, the outside numbers right here, 2x times 1, that equals 2x's. On the inside, these two right here, 6 times 1x, that equals 6x's. So I had 2x for my first answer, 6x for my second answer. Sorry, that didn't show up very well. 2 plus 6 does not equal 7. It's close. 2 plus 6 equals 8, but close isn't good enough. This has to be perfect. So for O for 2, and that's why I said I probably shouldn't have done these combinations first. Let's try the next one. You know what? I have a sneaking suspicion it's actually the last one. Let's try the last combination. Let's try 2x plus 3 and 2, whoops. Let me actually erase that, make it look a little better. Let's keep my same format. Notice my 2x and my 1x aren't changing. Those purple numbers have not moved. But now let's try, instead of 6 and 1, now let's try 3 and 2. And I think that this one right here is going to work. So double check. I have a guess that this one's going to work. O and I. On the outside, we have 2x times 2. Okay, 2x times 2. And if you can do this in your head, you don't have to write it out like I am. I'm just writing it out since this is the first time we're looking at it. On the inside right here, 3 times 1x. And look what I get. I get 4x for my first answer. I get 3x for my second answer. Does 4 plus 3 equal 7? It does. This is my magic answer, right? This is my magical answer. I got it. This is right. This was the good combination right here. Okay, now that was kind of annoying, right? We had to give 3 guesses. We had to check all of our guesses. It took 3 guesses to get it, but we eventually got it, right? You can see why this is kind of annoying. But the better you get at it, the more experience you have, you just kind of get used to it, and then it's not so bad. Okay, let's try number 2. And I will not do the silly guesses first. I'll do the normal. I'll try to point us in the right direction. The best that I know how. I'm getting the hiccups here. All right, example number 2. Let's see. I cannot divide these by anything, right? 10 and 6 could be both divided by 2, but 11 can't be divided by 2. So I'm just going to have to do guess and check again. All right. What are the ways here with the letter F that they got 10x squared? Oh boy, there's actually a couple different combinations, right? It could be 10 times 1, it could be 1 times 10, it could be 2 times 5, it could be 5 times 2. There's 4 choices for the letter F. Now, I'm just going to give you a hint. It's usually not the combination that has 1 times whatever the other number is. So this is probably 2 and 5. So I'm going to put 2x and 5x. I'm going to guess it's 2 and 5. On the end, look at our letter L. It's -6. So there's lots of ways to get -6. I could do +1. I don't know why this green marker is kind of not showing up well. Could be +1 and -6. It could be -1 and +6. It could be -2 and +3. Or it could be +3. Oh, no. -3 and +2. I guess I could flip around the 2 and the 3, but this will work fine. It's not a big deal. As long as I do 6 and 1 and 2 and 3 as my combinations, we'll get it. It's probably not the one that has 6 and 1. The number 1 is usually the last number, I guess. So I bet it's going to be one of these two down here, the 3 and the 2, or the 2 and the 3. Let's just maybe try the first one. I'm just going to go in order. Let's try -2 and +3, and we'll just see if that works. Now remember, the important target. This is our target. This is what we're shooting for right here. This is our oi in the foil, the O in the I. We're going to attempt to try the O in the I, and we're going to see, can we get our magic target is -11x. Okay, on this combination, we're just going to check this and see if it works. My first guess, 2x times 3, +3. Okay, that equals 6 x's. On the inside, these two right here, -2, +5x. -2 times +5x. Let's see, -2 times +5 is -10. Look what I get right here. I get 6x minus 10x. Does 6 minus 10 equal -11? No, it doesn't. 6 minus 10 equals -4. So this is not the right combination. So unfortunately, I didn't get it on the first try. Does that mean I give up? No. Does that mean I just immediately go to my phone and look it up on there? No. What that means is I should flip around my numbers, my green numbers. Right? The purple ones are going to stay. If I flip the purple and the green, it's just the exact same question. I just have everything. I just flip the parentheses. So that's why I only flip half of it. So now let's flip, let's put the +3 up here. And let's put the -2 back here. And let's see if I just reverse the 3 and the 2, if that works. Okay, same thing. We're going to try guess number 2. Let's check this one and see. I don't really like this orange marker. Let me go back to the black one. Orange one is sometimes a little bit harder to read. Right here, on the outside, 2x times negative, because it has a minus in front of it, -2. 2x times -2 is -4x. And then on the inside, this is +3 times 15. Or no, +3 times 5x. Sorry, I'm getting ahead of myself. +3 times 5x, that equals 15x. Oh man, look what happened. I'm so glad this actually happened. Look what I have, my O and my I. I got -4 and +15. If I add these together, I get 11x. Look how close that is. I'm supposed to have -11x. Do you know what that means? This means that we're actually done guessing. We know what the answer is. It's not this, but it's super close. So when this happens, when you get the right number, like I got positive 11 and it was supposed to be negative 11, but my sign is wrong, I have the right number. That means my numbers are right, but my sign is wrong. I got positive 11. I was supposed to get negative 11. What that means is your numbers are in the right spot. Your plus and your minus sign are backwards. So all I need to do is change. Instead of plus 3, I need to make it minus 3. Instead of a minus 2 in this parentheses, I need to make it a plus 2. And that will work. I'm not even going to check it because I know that's how it works. If you get the right number, but you have the wrong sign, it was supposed to be negative and I had positive, all that means is flip your symbols and then you're perfect. All right, there we go. Number 2. I have 2 more examples. I'm already at 20 minutes. Oh my goodness. Okay, I'll go a little bit quicker. Maybe I'll get one of these on the first guess. Leighton Crawford, I don't know if any of you guys out there know Leighton Crawford. Anytime he would get one on the first guess, he would always go, first try, and he'd always celebrate because he was really excited. Number 3, okay, I can't divide those by 3. 14 doesn't go into 3. 8 doesn't go into 3. Nothing's going to work. I can't divide them by 2 because 3 won't go with 2. I'm just going to guess. At the beginning, how did they get, for the letter F, how did they get 3x squared? I mean, it had to be 3 times 1, right? 3x times 1x, sorry. That's the only way to get 3. X squared is to do 3x times 1x. Okay, how did they get the letter L? How did they get 8? It could be 8 times 1. It could be 1 and 8. It could be 2 and 4. It could be 4 and 2, right? Oh, now, I didn't do this on the others. Look at what our target is. Look at what our combination has to equal this, right? Our OIT has to equal negative 14. That means all these have to be negative signs, right? These are all negatives. Negative 2, negative 4, negative 1, negative 8. These should all be negatives. Because if I put plus signs in here, I'll get positives. And I need to get an answer of negative 14. So let's just try. It's probably not the one that involves the number 1. Let's try this one right here. Let's try negative 2 and negative 4. And let's give this one a shot. Let's test it out. Our target number for the OIT is going to be this, negative 14. So we're going to test it out, O and I. Here's the O right here. 3x times negative 4, because it has a minus sign in front of it. 3x times negative 4 is, and I'm running out of space, is negative 12x. Sorry about that. Let me erase that. Do that again. I can do that better. The O was negative 12x. On the I on the inside, and if you're good enough where you can do this in your head, negative 2 times 1x. Negative 2 times 1 is negative 2x. Look what I got. I got negative 12, negative 2. That makes negative 14. And look, we got it on the first try. First try? Celebrate, Leighton Crawford. You did it. Perfect. Number 3, one guess. We got it on the first try. That's always a cause for celebration. Okay, number 4. I made this one a little tricky. Look at this. Can we actually divide all these numbers by something? We can. We can divide all those by 3. So first step, let's factor out 3. And then let's see what's left. 18 divided by 3 is 6x squared. 15 divided by 3 is 5. 12 divided by 3 is 4. Now, can I do it in my head now? No, because look, it still has 6x squared instead of 1. I was able to get the 3 out of there, so that helps me a little bit, I guess. Now when I go to make my guesses for FOIL, I'm not having to guess the combinations that equal 18. I'm having to guess the combinations that equal 6. It's probably 2 and 3. It's probably not 6 and 1. I'm going to put 6 and 1 at the bottom. It's probably 2 and 3. Let me move my camera down there so you can see all my guesses. So let's just try 2x and 3x. It's got to be that one. I doubt that. They usually don't do the one that involves the number 1. And then for the letter L, negative 4. You can see I have a negative 4 right there. That means my signs have to be different. It could be negative 2 and positive 2. It could be negative 4 and positive 1. It could be negative 1 and positive 4. It's got to be one of those combinations. I don't know which one. Let's just try for fun. Let's try... I don't think it's going to be this one, and I'll tell you why. If I had this in here, do you see how this parentheses still has a greatest common factor, right? I could still divide both those numbers by 2, and usually you don't have a final answer that can still be factored, so I don't think it's going to be this one. I don't even think it's going to be this one, right? If I put negative 4 and positive 1 right here, do you see how this parentheses is still factorable? I could still divide everything here by 2, so I don't think it's going to be this one either. If I had to guess, because book question writers, they don't like to give you a final answer that still has factoring stuff to do, right? I bet it's going to be this one. I bet it's going to be -1 and +4. Because look, these numbers can't be divided by anything. These numbers can't be divided by anything. I bet this is going to be it. I'm going to put a smiley face by that, and then let's see. Remember, here's our target. I'm shooting for this number right here. My O and I is going to equal -5x. And I hope this is going to work. Right here. 2x times 4. +4, that equals 8. And then in the inside, -1 and +3, -1 times +3x equals -3x. And so if you can see way out here, I have 8x minus 3x. 8 minus 3 is 5x's. And, oh, I'm so close. I got +5. My answer is supposed to be -5. So remember what we had on the other board. If you have the right number, but your symbol is wrong, I had +5. I needed to get -5. All that means is you just need to flip your signs, your plus sign and your minus sign, and then you've got it. This is it. If I really wanted to do FOIL, distribute, do the table, do the vertical method, and work it all out, I would get this as my answer. But I've done this enough to know that that is going to be correct. All right, thank you so much for watching. Sorry this turned into such a long video. I'm going to put some questions on the Big Ideas Math site for you to practice this. If you don't have access to the Big Ideas Math site, you can go to this website right here, kudasoftware.com/free.html. On the right-hand side, it should say Polynomials. They should have a section that says Factoring Polynomials, and then in parentheses it says Easy, and then it says Hard. This will be in the Hard section. If you want to click on the Factoring Polynomials, and then in the parentheses, the one that says Hard, you can try this, but it's not easy. So give it your best shot, and I'll be back tomorrow with some more practice of this because this is kind of a difficult topic. All right, thanks so much for watching.